In this video we're going to solve linear equations. Okay, so the goal is to get x by itself on one side of the equation. So we have a solution, x equals, and then a number, if there is a solution. Okay, so how do I do that in this first example? Well, I can see that there's only one x term, so I want to isolate that guy. So I got to get rid of the 7 and I got to get rid of the 2 by doing algebraic operations. So to get rid of a negative 7, I would add 7 to both sides. Okay, because negative 7 plus 7 is 0. So that leaves me with just 2x, and 4 plus 7 is 11. And the final step, I have 2 times x equals 11. Okay, so I got to divide by the coefficient of x, which will always be our last step, to divide by that coefficient of x. Alright, why does that work? Because 2x divided by 2 is just equal to x. So I get my answer as x equals 11 over 2. Now you'll notice when we first started this problem, I had a 2x minus 7 equals 4. And I did the opposite. Right? I did negative 7 and I did a plus 7 because I added 7 and that went away. Right? And then the last step, I divided by 2, but I didn't do the opposite, right? Because I'm doing a different operation. I'm dividing here. So when I divide positive 2x by positive 2, that's how I get x, okay? So make sure you remember when you're doing the adding and subtraction, you want to do the opposite, right? Because a negative 7 plus a 7 is 0. When you're doing division, you want this to do the same sign. If that were a negative 2, I would divide both sides by negative 2. It's always the same sign here. Okay? Alright, let's look at one that has it's a little more work. 7x minus 11 equals 2x plus 5. 7x minus 11 equals 2x plus 5. So the first thing I'll do, again, I want to get the goal is to get x on one side of the equation. So I have 2x terms this time. To get x on one side, I have two options. I could subtract the 2x from both sides. It would put all my x terms on one side of the equation. Or I could subtract the 7x. Okay, it's up to you. You'll get the same answer in the end. I'm going to choose to subtract the 2x term. 2x minus 2x is 0. You'll notice the signs are opposite because I'm subtracting 2x minus 2x to get 0. 7x minus 2x is 5x. Okay, and the reason I didn't subtract 7x, I could have, but I would have had a negative 5x on the right. In the end, you get the same answer. I prefer to keep my x term positive if I can. The next step would be to add 11 to both sides. So this gives me now 5x equals 16. And then the final step is to divide by 5. Okay. One thing that we haven't done yet is check our answers. We saw before how to do that. We can check this answer by plugging it back in to the original problem, 16 over 5 plus 5. Okay. I'm not going to take the time to do it. It's not a very nice problem to check because of those fractions. But that should work out. If we've done the work right, that should be the same on both sides of the equation. Okay. Number 3. Alright, so they're getting a little longer, a little more complicated. Anytime you have these parentheses, you're going to want to distribute, right? So first thing I do is distribute that 2. So that gives me 3x plus 6x plus 2. That's what happens when I distribute the 2 to 3x plus 1. And that equals 9x minus 8. The next step would be to combine my like terms, which I have here. 9x plus 2 equals 9x minus 8. And I'm going to stop right here, okay? Now, the next step to be, as we've been doing, would be to subtract the x term. So you could do that, minus 9x, but you see you're going to have a problem. So you could either stop here, and see you got a real issue here, because there's no way I can plug in a number x multiply it by 9, add 2, and get the same thing if I plug in the same number for x, multiply by 9 and subtract by 8. You'll never get the same thing. Right? If you can't see it at that step, you could do the next algebraic step, which would be to do that, subtract 9x from both sides. That's 0, and then you get 2 equals negative 8. So if you couldn't see it at that step, you should see it here. You can stop, because that doesn't make any sense. Right? 2 does not equal negative 8. So what does that mean? That means there is no solution for x. There is no value for x which makes that true. Okay? And how do you know that? Well, whenever you get a statement that looks like this, it just doesn't make any sense. When you get one number equal to another number and they're not the same number, then you know that there's no solution. Okay? You may see problems where you do that work. Let me just give you a real basic example. Right? Let's say I have something like this. Just real basic for the sake of time. Solve. So the first thing you do, you would distribute. Okay? And then this is a case where you get the same thing on both sides. You could do the next step, subtract the 2x, and you get 2 equals 2. But I can see here I got the same thing on both sides of the equation. So you can kind of tell that whatever value you plug in here for x, say 1, plug in a 1, you're going to get a true statement, right? 2 plus 2 is 4, 2 plus 2 is 4. But that goes for any value you plug in for x, which means every single value of x is a solution. So this would be the case where you would have all solutions. What I have over here in blue. Okay, so if you get something that looks like that, it doesn't make sense, no solution. Something that looks like that, the same thing on both sides, all solution. Okay? Alright, so look out for those. Okay, moving along. Problem number 4. First step, again, is to distribute. Now be careful with this negative. I see mistakes with this all the time. You got to distribute a negative. If you want, you can put a 1 in front of there. Think of it as distributing negative 1. 5 minus 3x, when I distribute the negative to 3x. Negative 1 times negative 6, positive 6. Or another way to think about it is that negative out front changes the sign of everything inside. The 3x was positive, now it's negative. The 6 was negative, now it's positive. Okay, nothing, didn't change anything on the right hand side. Next step is to combine these two like terms. That's 11. Okay, and now the step of adding the x term to both sides, adding or subtracting, in this case adding. So it's your choice. You can add 3x or you can add 2x. Doesn't really matter. If I want to keep my x positive, I would add it. So now I have 11 equals 1x plus 1. My final step will be to subtract the 1, and that will give me x equals 10. Okay, and I said always your final step will be to divide by the coefficient of x. Well, here the coefficient's 1, right? So once I did this step here, I ended up with 1x. So I didn't have to do that last step of dividing by 1. Okay, so once I subtract the 1 over, I'm done because I have x by itself after that step. This one would be an easier one to check because it's not a fraction, so maybe we can do the check for this one real quick. You should always do the check, especially if you have time on a test. 5 minus 3 times 10 minus 6, does that equal negative 2x, negative 2 times 10 plus 1? Alright, that's the question. So multiply that. That's 30 minus 6, which is 24. So does 5 minus 24, does that equal negative 2 times 10 is 20, negative 20 plus 1? Is that the same thing? 5 minus 24, negative 19. Negative 20 plus 1, negative 19. So it is, so we know we're right. So that's good. Alright, last one. Okay, so I'm going to distribute the 2, so that gives me 4x minus 2. Distribute the 4, negative 4x minus 16. Combine like terms, 4x minus 5 equals negative 4x minus 16. and then I'm going to add 4x to both sides. 8x minus 5 equals negative 16. Add 5, come up here, 8x equals negative 11, and the final step, divide by 8, and I get my solution as negative 11 over 8. I'll leave the check for that one up to you.